You've been there. A service call for a carriage position error. You can tell the head is clearing the peel arm, the linear slide is not binding, the belts are tensioned properly without damage to them, or the clamps. You've run the motor test, and now you have started to get to the root of your problem. Is it the motor or just the encoder? But you can't just guess with expensive parts. You need to see the heartbeat of the machine. The rotary encoder. This is TTOParts. What's up, everybody? Kyle here, TTOParts. Hey, today we're going to be building an encoder tester using an Arduino Mega board. Now we'll go through all the software and all this stuff, but why are we doing this? Well, you've been getting that printhead carriage position error and you don't know why. You've cleared all the mechanical problems, but still something's going on. Gotta be a motor or an encoder. So we're going to be able to build this tool to quickly diagnose it, fix it the first time, get yourself back to production. Let's get after it. To get started, you're going to need the following. First off, the Arduino Mega board. Next, a 16x2 LCD. That's just what we chose. It also has to have the I2C backpack on it. That's that bad boy right here. We used a breadboard to supply power. A handful of jumper cables. Finally, we can't forget our motor with our encoder. The printer needs to know the printhead's position down to the micron, and that's where the encoder comes in. Now, the encoder has a pattern disk in between two light sensors. Now, but it's not just picking up clicks, right? It's using Quadrature encoding sensing. Now, with two channels, A and B, offset by 90 degrees, we're able not just to pick up movement, but direction. Now, channel A goes high, channel B goes high, A goes low, B goes low. We're able to pick up all four of those state changes in our program, taking our 2048 resolution encoder up to an 8,192 line extreme precise encoder. Now let's look at the brain of the operation. There are three key things happening in this code. First, the hardware interrupts. We don't pull the pins. We use attach interrupt. This tells the Arduino to stop everything the nanosecond a pulse is detected. We never miss a count, even at high RPM. 2, the volatile variable. In the code, you'll see a volatile long encoder count. Because the count changes inside an interrupt and outside in the main loop, we use volatile so the processor doesn't try to take shortcuts, ensuring the LCD shows the exact count. And finally, the math. To make this user-friendly, we take those 8,192 counts and map them using a simple formula. This gives us a real-time degree readout on our LCD. All right, so let's discuss what we have going on here. We have our 16x2 crystal display. We've got our good motor, we've got our breadboard, and we've got our Arduino. So on the breadboard, all we're really doing is getting our plus and minus, right? Our 5 volts and our 0. And we're just separating that between what has to go to the encoder and then what has to go to the display. Pins 2 and 3, we have for A and B phases. So our black and white cables here are our SDA and SCL going to the display. We have another set of black and white, and that's our 5 volts and our ground on the Arduino. And then the only difference here is, like I said, we're just sending the power to where they need to go. And that's all it took to set this bad boy up. All right, so first up, we have our good, I know, functioning motor and encoder. Now, with everything set up, we've got our LCD ready, we've got our Arduino plugged in, we got it powered up. I have my cables tied to the encoder here, and we're gonna go ahead and give this a rotation. Now, and voila, we're getting feedback in degrees and in counts, just like our program says we should. Now, let's switch over to our problem encoder. Now, if you haven't already seen our short that we made about this, we had a printer come into the shop recently. We were getting nothing on the feedback loop on the printer, right? On the HMI, if you were to go to settings, diagnostics, printhead, and inputs, there are 2 values there you can track, and it's the encoder positions of the carriage as well as the printhead. Now on this guy, the printhead encoder was not giving us anything, and every time we booted up, it tried to move and just hung up printhead carriage position error. So for our customer, we swapped this out, knowing that this was bad, and we got them back up and running. But let's take a further look using our tester. So I'm gonna unplug the Arduino. I'm gonna unplug our power and our A and B on our tester. And we'll put our good motor to the side. Okay, put this one over here. All right, I have my cable here. I'm gonna plug my power cable onto the red. My 0 next, and then A and B. Okay, so I got everything plugged in. Now it's time to power up. So we'll just plug our board back in. We're gonna wait for our LCD to boot up, and it just did. So I'm at degrees, and as I rotate this motor, nothing's happening. It's just bouncing between 0 and 1 on the counts. So something's wrong with our feedback loop on this encoder. I don't know exactly. We can take it apart, or what we can do is we can take this motor, swap the encoder out for the other encoder that we know is working, and see what happens. That printer was blind, and that's why he was throwing up all the errors he was. We swapped that encoder, verified it with our tester, it's up and running. No more wasting parts, no more wasting time. Get back to production as quickly as possible. So if you missed that recent short I mentioned before, go ahead and check the link below. If you need parts, the code, or any other printer repair help, just reach out to us, the website, TTOParts.com, or email us at support@TTOParts.com. Work smarter, fix it faster, get back to production. We'll see you next time. Ciao.